To ensure that everyone is informed about important updates, it's encouraged to follow official NEC channels and avoid relying on secondary sources. Official communication channels include the NEC website at www.nec.org. Secondly, NEC email updates. Sign up for these at www.net.org/email updates. Thirdly, NEC social media channels, which include LinkedIn, Twitter, and Facebook. While there may be other websites or social media groups discussing NEC-related topics, it's crucial to prioritize official sources for accurate and timely information. By following official NEC channels, everyone can stay informed about important safety standards, industry best practices, and other critical updates that impact work and the safety of others. Thank you for your continued support and adherence to these guidelines. The NEC, or National Electrical Code, is a set of standards developed by the National Fire Protection Association, or NFPA, to ensure the safe installation of electrical wiring and equipment. These codes are updated every 3 years to reflect changes in technology and address new safety concerns. The NEC is adopted by many states and municipalities in the United States and is also used as a reference in other countries. Understanding and adhering to the NEC is crucial for anyone involved in electrical work, from electricians to engineers to building inspectors. It's not just about following the rules, it's about ensuring the safety of people and property. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for different types of electrical systems, such as residential, commercial, and industrial installations. One of the key areas covered by the NEC is wiring methods. This includes the types of conductors that can be used, the methods for installing them, and the requirements for protecting them from damage. The NEC specifies different types of wiring methods for different applications depending on the environment and the type of building. For example, in residential wiring, non-metallic sheath cable, often called ProMix, is commonly used for branch circuits. In commercial and industrial settings, conduit is often used to protect wiring from physical damage. Overcurrent protection is another critical aspect of the NEC. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices are sized to trip or blow when the current exceeds the safe level for the circuit, preventing damage to the wiring and equipment and reducing the risk of fire. The NEC specifies the requirements for overcurrent protection based on the ampacity of the conductors and the type of equipment being protected. Grounding is also essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding. Proper grounding helps to prevent electrical shock and reduce the risk of fire. Equipment installation is another important area covered by the NEC. The NEC specifies the requirements for installing various types of electrical equipment, such as lighting fixtures, receptacles, and appliances. These requirements are designed to ensure that the equipment is installed safely and correctly and that it operates as intended. The NEC also includes requirements for special occupancies, such as hazardous locations, healthcare facilities, and swimming pools. These occupancies have unique electrical safety concerns, and the NEC provides specific requirements to address these concerns. For example, in hazardous locations, such as areas where flammable gases or dust are present, the NEC requires the use of explosion-proof equipment and wiring methods to prevent ignition. Healthcare facilities have stringent requirements for electrical systems to ensure the safety of patients and staff. The NEC includes requirements for essential electrical systems, which provide backup power to critical equipment during power outages. Swimming pools also have specific electrical safety requirements to prevent electrical shock hazards. The NEC requires the use of ground fault circuit interrupters, or GFCIs, to protect circuits near swimming pools and other wet locations. The NEC is a complex and comprehensive document, and it can be challenging to navigate. That's why it's important to stay up to date on the latest changes and interpretations. There are many resources available to help you understand the NEC, including training courses, seminars, and publications. It's also a good idea to consult with a qualified electrical inspector or engineer if you have questions or concerns about the NEC. Understanding the NEC involves grasping key concepts and terminologies. Firstly, ampacity refers to the current carrying capacity of a conductor, expressed in amps. This is the maximum amount of current a conductor can safely carry without exceeding its temperature rating. Secondly, voltage is the electrical potential difference between 2 points in a circuit measured in volts. Common voltage levels in residential settings include 120 volts for lighting and small appliances, and 240 volts for larger appliances like ovens and dryers. Thirdly, impedance is the total opposition to current flow in an alternating current circuit measured in ohms. It includes resistance, inductive reactance, and capacitive reactance. Understanding impedance is crucial for calculating voltage drop and ensuring proper circuit performance. Fourthly, grounding refers to connecting electrical equipment and systems to the earth, providing a low impedance path for fault current to return to the source. Proper grounding is essential for preventing electrical shock and minimizing the risk of fire. Fifthly, bonding involves connecting metallic parts of an electrical system together to create an electrically conductive path. Bonding helps to equalize voltage potentials and reduce the risk of electrical shock. Sixthly, overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a safe level, preventing damage to wiring and equipment. Seventhly, GFCI, or ground fault circuit interrupter, is a device that detects ground faults and interrupts the flow of current to prevent electrical shock. GFCIs are commonly used in wet locations such as bathrooms, kitchens, and outdoor areas. Eighthly, FSI, or arc fault circuit interrupter, is a device that detects arc faults, which are dangerous electrical conditions that can cause fires. SIs are designed to protect against fires caused by damaged or deteriorated wiring. Ninthly, conduit is a protective raceway used to enclose electrical wiring. Conduit can be made of metal, plastic, or other materials, and it provides physical protection for conductors. Tenthly, raceway is a general term for any channel designed to hold electrical wires or cables. Raceways can include conduit tubing and other types of enclosures. Understanding these fundamental concepts is essential for working safely and effectively with electrical systems. Always consult the NEC and other relevant standards for specific requirements and guidance. To further illustrate the NEC application, let's consider several practical examples. One example is residential wiring for a kitchen. The NEC specifies that kitchen circuits must be protected by GFCIs because of the presence of water and the potential for electrical shock. Countertop receptacles must be supplied by at least 220 amp small appliance branch circuits. These circuits should serve only countertop receptacles and not other outlets or lighting fixtures. Another example is commercial lighting in an office building. The NEC requires that lighting fixtures be installed in accordance with manufacturer's instructions and that they be properly grounded. Emergency lighting systems must be provided to ensure safe egress in the event of a power outage. The NEC also specifies the requirements for lighting control systems to promote energy efficiency. A third example is industrial motor installation. The NEC provides detailed requirements for the installation of motors, including the sizing of conductors, overcurrent protection, and disconnecting means. Motor circuits must be protected against overloads and short circuits. The NEC also specifies the requirements for motor control centers and variable frequency drives. A fourth example is wiring in a hazardous location. In areas where flammable gases or dusts are present, the NEC requires the use of explosion-proof equipment and wiring methods. All electrical equipment must be rated for the specific hazardous environment. The NEC also specifies the requirements for intrinsically safe circuits, which are designed to limit the energy available to ignite flammable materials. A fifth example is solar photovoltaic, or PV, systems. The NEC addresses the installation of solar PV systems, including the requirements for disconnecting means, overcurrent protection, and grounding. PV systems must be installed in accordance with manufacturer's instructions and must comply with all applicable codes and standards. Understanding these examples can help you apply the NEC to real-world situations and ensure that electrical systems are installed safely and correctly. It's important to remember that the NEC is a minimum standard and that additional safety measures may be necessary in certain situations. Staying informed about the latest changes to the NEC is essential for all electrical professionals. The NEC is updated every 3 years, and each new edition includes revisions and additions to address new technologies and safety concerns. One way to stay informed is to attend training courses and seminars offered by electrical organizations and manufacturers. These courses can provide you with a comprehensive overview of the latest changes to the NEC. Another way to stay informed is to subscribe to industry publications and online resources. These resources can provide you with timely updates on code changes and interpretations. You can also join online forums and discussion groups to network with other electrical professionals and share information. Additionally, you can participate in the NEC revision process by submitting proposals for changes to the code. The NEC is developed through a consensus-based process, and anyone can submit a proposal for a change. By staying informed about the latest changes to the NEC, you can ensure that you are providing the safest and most up-to-date electrical installations. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. Staying current with the latest changes is crucial for maintaining safety and compliance.